Okay, so this is number 29, 4.5, 4.5, practice C number 29, and the problem is x squared minus 3 equals a. And I'm supposed to find the values for a, for which the equation has two real number solutions. So I want a to be two real numbers. Anybody got any ideas on this one? So let me start out then. Well, what does it mean that I want the solution to be a real number? Yeah, Valentina. No. A whole number is what you just called it. Is a whole number. No, that's just a positive number. I want to know what makes a number real. Yeah, Juliet. No, that's a rational number. Okay, Rachel.
They're not imaginary?
They're not imaginary. and that's exactly the answer. So when we have a number system, and maybe a little bit unfair because we're doing complex numbers kind of out of order. But I'm going to try and do this, see if this works out. The entire universe of numbers in which we are going to deal pretty much all the way through calculus. It starts to get a little bit more weird after that. But it's called the complex numbers system. And within the complex numbers, we have two main divisions. We have real and we have imaginary. Imagine, G-N-A-R-Y. Real and imaginary. Imaginary numbers we're going to talk about after we're done with these homework problems, but those are things that deal with the letter I.
Oh.
I is the square root of negative 1. There's no such thing as a square root of negative 1. I mean, I shouldn't say there's no such thing. There is. It's a complex number. But the square root of negative 1 certainly cannot be graphed. We can't put that on a graph. It doesn't exist anywhere on a graph. But under real numbers, we have all different kinds. We have, I have to remember here, the largest subset of real numbers. Well, okay, we actually have two big subsets. We have irrational numbers, and we have rational numbers. Rational numbers are any numbers that can be expressed as a fraction, one integer over another integer. Irrational numbers cannot be expressed as a fraction. An irrational number, square root of 2. One of those things that just repeats on forever, right? And repeats on forever without any pattern. Right? Some numbers repeat forever, like 1/3 is a rational number. If I put it in decimal form, that equals 0.333. On and on forever. It repeats forever, but it's a pattern that it repeats. An irrational number repeats without any pattern. The most famous irrational number, please. There you go. Okay. All right, so we're all on top of that. Rational numbers. So in terms of rational numbers, you have a subset of integers, and then a subset of whole numbers, and a subset of natural numbers. All right. So that's what we're talking about with the number system. I want A here to be a real number. So I want it to be on this side of my complex number system. Okay? So what? Any thoughts on what I should do to figure this out? Okay, so so here's what I'm going to do. What I'm going to do is I'm going to go x squared, I'm going to add 3 to both sides, is equal to a plus 3. Is that all right? Then I'm going to take the square root of both sides. So this is going to be, because I want to know what x is going to be here, right? So x squared is equal, the square root of x squared is equal to plus or minus the square root of a plus 3. So I have x is equal to plus or minus the square root of a plus 3. So if I want the answer to this to be, if this what, I want two real number solutions. What does A have to be? What can A not be?
Negative number.
Well, it could be a negative number, right? If I made A negative 1,
It can't be a negative number greater than.
It
It can't be negative 4. It can't be more than 3.
okay. All right. So here's how I would figure it out algebraically. I know that I want this number here to be, I want A plus 3, I want it to be greater than 0. Right? If it's less than 0, I'm in trouble. If A plus 3 is less than 0, I have a negative number under my radical sign, it's imaginary. Right? Is everybody with me with that? And if A plus 3 is equal to 0, I still don't have two real number solutions, I only have one. Because plus or minus 0, 0 is 0. 0 doesn't change. Am I making sense here? If somebody asked me a question. So A plus 3 has to be greater than 0. Well, now it's an easy thing to do. So A, I'm going to subtract 3 from both sides. A has to be greater than negative 3. Anything less than negative 3, I'm not going to have a real number solution. Does that make sense?
Yeah.
Yeah? All right. This will be very important when we get into rational functions. Because, yeah, okay. Yeah. Cameron.
So you don't have to find like an equation or anything with x or a, or I mean like using x, so you can just use the a plus 3.
Yes.
Oh,
Yeah. I mean, what I had to know to do here is to set it up like this and then take the square root of both sides. Because I wanted to make sure that I had two real solutions. Okay?